In BOE examination, in question papers by many states, you are supposed to use the steam table. They would either give you the steam table during the examination, or you are asked to bring your own steam table. In the bottom line is you need to know how to use the steam table to answer the BOE questions in those states. Gujarat, Maharashtra, Chhattisgarh, Andhra Pradesh, these are the various states from where, in fact, many other states also, uh, the value of various steam properties are not given in the questions. So you are supposed to refer the steam table and get those values. So in this video, I am going to show you how to use the steam table uh, to solve various questions related to steam properties. And sometimes in some of the BOE questions, you are required to interpolate because the value for which you need to find out the stream properties are not available in the stream table. It is either some decimal less or more. So you have to use the interpolation. I'm also going to show you how to do the linear interpolation. It's very easy as such, but I'm going to show you that, right? So first of all, I would start with sample questions. This is a question that has come in Maharashtra BOE, where a particular stream at 8 kg per centimeter square absolute pressure, and it's having a 0.9 dryness fraction, and it is passed through a reducing valve, and the reduced pressure is 3 kg per centimeter square absolute. They are asking you to find out what is the dryness fraction after the reduction process, right? So it's basically a throttling process. Now, first of all, here you need to find out the enthalpy and other things. So we need to know how to use the steam table. So I'm going to first of all show you what a steam table is. This is something which every one of you should have. When you are preparing for BOE, you must have your own steam table to refer, right? It will give you practice as well as it will be required to solve various questions. So you can ask for a steam table. You can buy it from Amazon. It is available. Preferably get an SI unit steam table. If you can get a steam table which is having both SI and MKS unit, nothing better than that. But okay, an SI unit steam table will be fine. So in a steam table, the first table you are going to see is basically, as you can see, is a temperature based steam table, right? In this, the first column is the saturation temperature, right? So this is the saturation temperature against which various properties of steam has been given. So let us first know what are the various properties those are given. The second column in this table 1 will be the corresponding vapor pressure, the pressure for which the saturation temperature is taken the reference, right? That will be the second column. The third column and the fourth column is for specific volume. The third is for specific volume of saturated water, denoted by VF. Saturated water means the water is at saturation temperature, right? That is the condition for which the specific volume, that is meter cube per kg, volume per kg, is given in this column. The next column is for the specific volume of saturated steam. So at the same pressure and saturation temperature, when the steam is completely dry and saturated, that is the specific volume given in this column and denoted by Vg. The next three columns are for the specific enthalpy, right? The first of this is the specific enthalpy of saturated water. Again, remember, when the water is at saturation temperature, that is the condition, right? So corresponding pressure, saturation temperature, at that condition, what will be the enthalpy, that is the total heat content right from 0 degrees centigrade to that temperature, that is given in this column. The next column is the specific enthalpy of evaporation. That means from that saturation temperature, from the water condition to completely dry saturated steam condition, what is the latent heat requirement, that is given here, denoted by HFG, right? The first one, the saturated enthalpy of water, is HF, and the specific enthalpy of evaporation is HFG, and the last column is Hg, which is the enthalpy of saturated steam, which is nothing but the summation of HF and HFG, right? Then you see the entropy is given, specific entropy is given, entropy per kg. The first is the specific entropy of saturated water. The next is specific entropy of evaporation, and the final is the specific entropy of dry saturated steam. Now, if you want to understand the steam table, certain things we need to understand again, right? So let us go back to the steam table, which is pressure-based steam table. The pressure-based steam table is nothing like nothing different to the table 1. Only thing is, in this case, the column 1 is the absolute pressure in bar. Column 2 is its corresponding saturation temperature. There is the corresponding saturation temperature. Now what you need to understand is that as the pressure increases, what are the conditions of these various properties? Those we have discussed. The first thing you need to note that as the pressure increases, the saturation temperature increases. Next, you see the specific volume of water. As the pressure increases, the volume increases. Next, you see the specific volume of steam. Now here you see, as the pressure increases, the volume decreases, right? The pressure is increasing, steam is getting denser naturally. The next three column, that is the specific enthalpy column. For specific enthalpy of water, with increase in pressure, the enthalpy of water is increasing. Higher the pressure, more would be the specific enthalpy of saturated water. But if you see the specific enthalpy of evaporation, with increase in pressure, the specific enthalpy of evaporation decreases. And it goes on decreasing, and at a critical pressure, it becomes zero. All of you know that. If you see the saturated steam condition, the specific enthalpy of saturated steam, you can see in this particular table that it is increasing. As the pressure is increasing, it is increasing. But if you go farther up, right, if you just follow through the pressure, go farther up, you are going to find that at a pressure of 30 bar, it is increasing. And from 30 to 34 bar, it is remaining same. And after 34 bar, with increase in pressure, it starts decreasing. So please remember this, that saturated steam enthalpy, that is Hg, it first increases with the pressure, increase in pressure up to 30 bar. Above 30 bar or above 34 bar, it starts decreasing, right? Now I will show you another table, that is table 3. In some of the tables you might find it is the specific volume of superheated steam. So again, various pressure and corresponding superheated steam temperature, the specific volume is given. And in table 4, you are going to find the specific enthalpy of superheated steam. In some of the steam tables, you might find both the specific volume, the enthalpy, as well as entropy of the superheated steam. Now, the one which you are going to need the most is the pressure-based steam table. That is table number 2. Right? Most of the questions you are going to find that, there would be some condenser questions. You might have to refer the table number 1, that is the temperature-based steam table. But most of the questions you need the pressure-based steam table. So let us now see how to use the steam table with this particular question. Here few things we need to know, right? Couple of things we need to know to answer this question, because in this question they are asking that a particular steam is going through a reducing valve, so the pressure is reduced from 8 kg per centimeter square absolute to 3 kg per centimeter square absolute. So this is a throttling process, and you need to know that in a throttling process the enthalpy before and after throttling remains same. It doesn't change, right? Second thing you need to know is how to calculate the enthalpy of a wet steam, because they have mentioned it is a 0.9 dry steam. That means it's a wet steam. So how to calculate the enthalpy of a wet steam? That is HF plus X into HFG. X is the dryness fraction. So we need to calculate the specific enthalpy of saturated water and the dryness fraction times the specific enthalpy of evaporation. That will give you the enthalpy of a wet steam. In some of my other videos in future, I will talk about the properties of steam, and I will show you how to calculate the enthalpy of wet steam, how to calculate the enthalpy of superheated steam, and so on. Now, the pressure is given in kg per centimeter square absolute. Now, if you are using a bar, I mean a SI unit table, that means the pressure would be given in bar absolute. So good thing is it is given absolute, so we don't need to change that. But we need to change from kg per centimeter square to bar. And we have discussed earlier that when we multiply kg per centimeter square with 0.981, we get bar. So 8 kg per centimeter square absolute becomes 7.85 k bar absolute, and 3 kg per centimeter square absolute becomes the 2.94 bar absolute. And one more understanding is that when the pressure is reduced from 8 kg, or in this case 7.85 bar to 2.94 bar and up to 30 bar, as the pressure increases, the enthalpy is increasing. That means the 7.85 bar will have more enthalpy as compared to 2.94 bar, right? So in such cases, either the dryness fraction increases by a little bit, right? Or sometimes you might see that it becomes dry saturated steam. Sometimes you even find it becomes superheated steam. In fact, that is how the dryness fraction is calculated for a low pressure steam. So let us go back to this. Now what we need 7.85 bar HF and HFG to calculate the enthalpy, 2.94 bar HF and HFG to calculate the enthalpy, and then we can equate, right? As HF plus XHFG at 7.85 bar will be same as HF plus XHFG at 2.94 bar. One X we do not know, the other we know, right? So in that case, let us first take a look at this particular table where we are having this 8 bar condition, right? Since it is 7.85, that means it is less than 8 but more than 7.8. So we have to now interpolate between these two values, 7.8 and 8, to get the 7.85 value, right? So I will show you how to interpolate. Now first of all, you note down what is the HF and HFG at 7.85, 7.8 bar, and what is the HF and HFG at 8 bar. We can see that in HF, when we are talking about HF, the pressure increases from 7.8 to 8, the enthalpy increases. So 7.85 will be more than 7.8, right? The enthalpy, specific enthalpy of saturated water will be more. So what we write? We write enthalpy at specific enthalpy of water at, that is HF, at 7.85 is equal to 716.3. This is the enthalpy at 7.8, but now it will be more, so plus. How much more? So from 7.8 to 8, the enthalpy is increasing 720.9 minus 716.3. Now this is increasing when the pressure is increasing by 0.2 bar, right? So how much increase will be there from 7.8 to 7.85? That is 0.05 bar. So that is a unitary method. This divided by 0.02 into 0.05 will give you the increase in value for 0.05 bar increase, right? You add this, you get the value. This is the interpolated value. This is a very simple method. Only thing is, just first of all observe whether it is increasing or decreasing. If it is increasing, plus. If it is decreasing, minus. How much it is increasing or decreasing, that difference over which pressure, and multiplied by how much increase of pressure you want to find out. For example, for HFG, it is 2050.1 kilojoule per kg at 7.8, but HFG we know as the pressure increases it decreases, therefore it will be minus. What is the difference? Difference is 2050.1 minus 2046.5. This is happening over a pressure of 0.2 bar increase, so divided by 0.2 into 0.05 will give you the interpolated latent heat at 7.85 bar. Similarly, we'll have to find it for 2.94. So we select the pressure based steam table where we get the 2.9 and 3, right? Different steam table will have different. In some you might have 2.5 and 3. It's possible, right? But in particular this table we are having 2.9 and 3. So we write down this 2.9 and 3 bar HF and HFG. Then as we have shown you earlier. Similarly, we interpolate at 2.94 bar 556.5 plus, because it is increasing, the difference over 0.1. So what will be the difference in 0.04? Because 2.94 is 0.04 more than 2.9. Similarly, we can calculate the HFG, right? And now we know what will be the HF and HFG at 2.94 bar. But we do not know the dryness fraction, but we know that the enthalpy will be same, right? So now we can equate it like this, keeping the dryness fraction, assuming the dryness fraction as x, right, for 2.94 bar. So we equate the 2.94 bar enthalpy HF plus HFG is equal to the 7.85 bar enthalpy, that is 717.45 plus 0.9, because the dryness fraction is given, and from here I can calculate the x as 0.93. So you have noticed that the dryness fraction has increased. Instead of 0.9, it has become now 0.93, right? So with that, I conclude this section. Similar tips would be given in future also to make the mathematics easy in your BOE questions. Thank you.